Okay, this is section 13.2, derivatives of vector functions, and this is practice problem number 17. Okay, in this one we want to find the equation for the plane that is perpendicular to this vector function going through this particular point. Well, in order to do this, of course, we're going to find the derivative of the vector function. That's going to be a vector that points in the direction of this curve, and of course that's going to make it perpendicular to the plane. And of course the normal is always perpendicular to the plane. So we'll have the normal and we'll have a point in the plane, and that's sufficient. First thing we need though, we're going to have to figure out what the normal is at this point, and that's going to involve knowing t. So let's look at the function. T has to be equal to pi at this point. For this point to be on this vector function, t will have to be pi. Let's check the other 2 points. If this is pi, the cosine of 3 pi is -1 times 2. There it is. And of course, any number of whole number pi's in the sign is going to be 0. So there we go. If t is equal to pi, then we generate that point right there. Okay, so here's the first derivative of t, or of r, and that's going to be 6 times the cosine of 3t. This will be 1, and this will be -6 times the sine of 3t. And of course, r prime at pi will give me the normal. So this will be equal to the normal vector, the one we want for the plane. And plugging pi in, this is going to be, again, odd pi's, so that makes it -1 times 6, so it's -6. This is always 1. And any odd number of pi's will make it 0 for sine. So -610 is the direction of the normal. Now I just have to write the general equation for a plane, and that's going to be ax plus by plus cz equals d. And these are the direction numbers. So it'll be -6x plus y equals d. And in order to figure out what d is, now I just need to plug in the point it runs through. So I'll plug in 0 for x, so this will be 0, plus pi for y, and that equals d, so clearly d equals pi. So that makes our final equation for the plane -6x plus y is equal to pi. And that'll satisfy it. This plane is perpendicular to this vector function, and it's perpendicular to it at this point right here, which is contained within the plane. So that satisfies exactly what we were after.